Dear student, welcome to my channel. Today we are going to practice some word problems based on surface areas and volumes. So the first question is, two cubes, each of volume 64 cubic centimeter, are joined end to end. Find the surface area of the resulting cuboid. So for this, we have to draw the two cubes. So these are the two cubes. If we draw it in this way, 3D shape, we can give the 3D shape of this two cuboid. So we'll get the figure in this way. So this resulting figure, it is looking like a cuboid now. So we have to find the surface area of the resulting cuboid. First of all, from the given information, we have to find the side of each cube. So we'll write let the side of each cube, also we can write each cube be r. As it is given centimeter, so we can write centimeter. So let the side of each cube be r centimeter. Therefore, we can write r cube equal to, because we know that the volume of a cube is r cube, so we can write r cube equal to 64. R cube equal to 64. From here we can write r cube equal 4 cube. This implies r equal 4. So we can write here centimeter. So this is the side of each cube and it is 4 centimeter. Now if we see the figure again, then we can see that here it is 4 centimeter. As the two cubes are joined, so that one also 4 centimeter. And from any point, suppose from here, if we take, then this is the length. So length is 4 plus 4 equal to 8 centimeter. This is, if we take as breadth, so it is 4 centimeter. And the height also 4 centimeter. Only the length is 8 centimeter. So this is the dimension of the resulting cuboid. Now we'll find it. We can write, therefore, the surface area of the resulting cuboid equal. So what is the formula of the total surface area of a cuboid? In my previous video I have given all these formulas. So it is 2 into LB plus, so let me write it, 2 into LB plus BH plus LH. Now we'll put the values. So we'll get L equal to, here 4 plus 4 means that one is the length, so it is 8 into base. So for breadth is 4 centimeter. So 4 plus breadth is 4 into h is also 4 plus L is 8 into h is 4. So that one. Now we'll calculate only 4 8 is 34 plus 16 plus 32. Here 32 equal 2 into, we'll add it. So here 64 plus 16 gives us 80. So it is 80 equal to 160. What it is? Surface area. So we write here centimeter square. So this is the answer. So I think you can understand. Now we'll do number 2. So the question number 2 is, a vessel is in the form of a hollow hemisphere mounted by a hollow cylinder. The diameter of the hemisphere is 14 centimeter and the total height of the vessel is 13 centimeter. Find the inner surface area of the vessel. So according to the question, we have to draw the figure first. So it is given a vessel is in the form of a hollow hemisphere. So we'll draw it in this way. So let it be the hemisphere. Then it is given and by a hollow cylinder. It is mounted. Here it is written mounted by a hollow cylinder. So here another cylinder is there. We'll draw it in this way. So here is the cylinder, means cylindrical part. So this is the figure in this way. Now what are the dimensions given? The diameter of the hemisphere. The diameter of the hemisphere, which one is the diameter? This is the diameter. So diameter is given 14 centimeter. So we'll get the radius. So radius is 7. We can write here 7 centimeter. Mean the radius is 7 centimeter. Another is given and the total height of the vessel is 13 centimeter. Mean from here it is 13 centimeter up to this. Mean the total height. So total height, this is the level. So total height of the vessel is 13 centimeter. Now we have to find the inner surface area. So here two combinations of the figures are there. One is cylindrical and another hemispherical. So both of these surface area is curved surface area. So you have to find the curved surface area of the cylinder and the curved surface area of the hemisphere, and then we have to add it. Now here the hemisphere, for hemisphere the dimension is given 7 centimeter. We need only radius of the hemisphere. But in case of cylindrical part, it is directly not given, but we can find the height of the cylinder as it is given. The total height is 13 centimeter. So we can subtract 7 centimeter, mean that one also 7 centimeter. So if it is 7 centimeter, then the height of the cylinder will be 13 minus 7. So we'll get the height. So we can write here the height of the cylinder as 13 minus 7 equal 6. Here we can write 6 centimeter is the height of the cylindrical part, and the radius of the cylinder will be equal to the radius of the hemisphere. So these are the measurement given. Now we can find the inner surface area. Directly we can write the inner surface area. Inner surface area of the vessel equal. So as I told you that we have to find the curved surface area of the cylinder and the curved surface area of the hemisphere, and then we can add it. So let me write the cylindrical part first. So what is the curved surface area of a cylinder? It is 2 pi RH. So we'll write here 2 into, directly we can write 2 into 22 by 7, 2 pi, our R is 7 and H is 6, that one, plus we'll add it. Now the curved surface area of the hemisphere. So what is the curved surface area of the hemisphere? We know that the surface area of a sphere is 4 pi r square. So hemisphere is 2 pi r square. So we'll write here 2 into 22 by 7 into 7 into 7. So it is 2 pi r square. Now equal. Here you can see 7 cancel. Here also we can cancel 7 and 7. So if we multiply it here, so here 44 into 6, we'll multiply it separately. So we'll get 264. So here it is 264 plus, now from here also 44 into 7. So we'll do it here in the rough side. It is 308. So it is 308. So this is, as it is given the surface area, so our unit will be centimeter square. Now by adding we'll get 7 and then 572 is the surface area of the inner surface area of the vessel. So this is the answer. Now we'll start question number 3. In question number 3, it is given that a toy is in the form of a cone of radius 3.5 centimeter mounted on a hemisphere of same radius. The total height of the toy is 15.5 centimeter. Find the total surface area of the toy. So according to the question, first we'll draw the figure. So it is given that the toy is in the form of a cone of radius, that one mounted on a hemisphere. Mean hemisphere will be in the lower side. So let me draw the figure. So this is the figure. This is the hemispherical part, and the upper one is the conical part. Now, as it is given, the radius is 3.5 centimeter, and it is same radius. It means the radius of the hemisphere and the radius of the base of the cone is same. It means it is given 3.5 centimeter. Another information is that the total height of the toy is 15.5 centimeter. Here it is given 15.5 centimeter. So from here up to this, it is 15.5 centimeter up to the total height, this level. So this is 15.5 centimeter. From here we can get the height of the cone, because that one is, this is also the radius of the sphere, and that one also 3.5 centimeter. So by subtracting 3.5 centimeter from the total height, we can get the height of the cone. Now one by one we'll write. First, the condition we'll write. The radius, as it is given, the radius, cone of radius. So radius of the radius, we'll write the radius of the cone equal to the radius of the sphere. You can write in 2 lines also. Equal what given? It is given 3.5 centimeter, because it is same. So radius finished, and it is given the total height. So that one also we can write the height of the cone. So what will be the height of the cone? So it will be, as the total height is 15.5 centimeter, we can subtract this radius to get the height of the cone. So we can write 15.5 minus 3.5 centimeter equal 12 centimeter. So we got the height of the cone. Now, as we are getting, what is the question? Find the total surface area of the toy. So when we will find the total surface area, so we have to find the curved surface area of the cone as well as the curved surface area of the hemisphere. So in case of curved surface area of the cone, we need to know the slant height. That one is slant height. Slant height is not given. So we'll find the slant height. The slant height directly will write the slant height of the cone equal. Downside will write equal. So slant height of the cone by Pythagoras theorem, we can get it as it is the slant height L. So L equal to square root of height square plus radius square. So we'll write here equal to square root of height is 12. So we'll write 12 square plus radius is 3.5. So we'll write 3.5 whole square. So let us find it separately. The slant height equal square root of 144 plus 3.5 whole square equal to 12.25. You can do it in the rough side. Equal. So if we add it, so we'll get 156.25 square root of 156.25. Now what is the square root of 156.25? So we can do it here. How to find the square root of 156.25? Let us see. We'll do it. So we'll write here 156.25 because some of you can get difficulties here to find the square root. That's why I am showing. Otherwise, I can write it directly. So you see how to find it. So here decimal is there. So appearing from the right hand side, the last one is 1. So we'll put here 1. Then here 1, 1 the 1. We'll write here 1. And then we'll take 56 here directly. Now here again, and we have to write here the double of 1, and it is 2. Now you have to choose one number so that it becomes 56 or less than 56. So it should be 2. Then here if we put 2 here, then here will be 44. Now here 1, 2, and now we'll put here 25. So it is 12.25, and here we'll put point. Actually here no decimal. There will be no decimal. Now again in the similar way we'll proceed. Then we'll write here the double of 12, and it is 24. And if we put here 5 multiplying by 5, so it will give us 1, 2, 2, 5. So we'll put here 5. So 1, 2, 2, 5. So what is the square root? We got it is 12.5. So we'll write here 12.5. This is the slant height. The unit is centimeter. So we got all the dimensions. Now we can find. Now we can write directly the total surface area of the toy. Therefore, the total surface area of the toy equal. So first we will write the surface area of the conical part. So it is pi r l plus now the hemispherical part, and it is 2 pi r square. R is same. equal. Now pi, it is given in the question 22 by 7, and if it is not given, then you have to put 22 by 7 into r, radius is 3.5, into the slant height is given. We find it slant height 12.5, so we'll write here 12.5 plus, here it is 2 into 22 by 7 into r square means 3.5 into 3.5. Now equal, here it is, we can cancel 7 by 35, so it is 0.5, and here also we can cut it, here also 0.5. Now if we multiply 22 with 0.5, so we'll get 11 into 12.5 plus, then here 2 into 22 equal to 44 into 3.5 into 0.5 equal 35. So 2 decimal is there, so 1.75. Directly also we can do it in the rough side. So now we'll multiply that 2. So it is 125. We'll put the decimal later on. 11. So it is 1375. One decimal is there. So here will be 137.5. 137.5 plus 44 into 1.75. So 175 into 44. 0077, then 2 decimal, so here it is 77. So 77. So if we add it 77 with 137.5, so let us add it here 5, 214 point. So it is 214.5. Now we'll put the unit as it is surface area, so centimeter square. So this is the answer. So I hope you can understand. Now we'll start question number 4. In question number 4, it is given that a cubical block of side 7 centimeter is surmounted by a hemisphere. What is the greatest diameter the hemisphere can have? The first part of the question, and it is given find the surface area of the solid. So I have already drawn the figure, as it is little complex, that's why I have already drawn it. So this is the cubical block, you can see this is the cubical block, and that one is the hemisphere as it is surmounted. So you can see it to clear it. Suppose this is the cube and this is the hemisphere, so it is in this way, that is the diameter of the hemisphere. The diameter of the hemisphere is equal to the side of the cube. It is fitted in this way, mean that part also touching and that part also touching. So it means that the diameter of the hemisphere is equal to the side of the cube. So here also you can see these two lines I have drawn. If you want to draw, no need to draw these two lines. Actually for explanation I have drawn it. So you can see from here up to this is the diameter of the hemisphere, and this is equal to the side of the cube also. Mean the first part, the answer of the first part will be as it is given, what is the greatest diameter the hemisphere can have? The answer will be 7 centimeter, because it is equal to the side of the cube. So we'll write the first part what is the greatest diameter the hemisphere can have? The answer will be the greatest. We can write in this way, the greatest diameter equal, we can write it equal, it is 7 centimeter. It is given 7 centimeter. So this is the first part. Now in the second part, find the surface area of the solid. Now we have to clarify the figure first. So cube, it is a cube. The hemisphere is surmounted. So first we think about the cube. So what is the surface area of a cube? We know that a cube has 6 faces and all the faces are equal, and the formula is if the side is L, then the total surface area is 6L square. But here you can see one face is involved in sphere. So we'll leave it first. Then what is the remaining faces? 5 faces are there. So 5 faces are intact. There is no touching anything. So we can write it 5L square, mean 5 into side square. Now what about this face? In this face we can see here some parts are there, here in the corner also another part, here also another part. So this part will be added in our answer, and we will add the curved surface, mean surface area of the hemisphere. So that will be the answer. We have to add all this. Now another thing, here you can see in this face, this is the circular part. This is the circular part. So if we subtract this circular part from this face, mean area of this face, then we'll get this corner one. So this corner one we can get it, and that part mean the surface area of the hemisphere. So surface area of the hemisphere usually we can get, it is 2 pi r square. So this is the way one by one we'll write it. Now directly we can write the, as it is given, the surface area of the solid. So we can write the surface area of the solid equal, let me write here equal because it is needed, long terms are there, so we'll write here. So first what I told you, the 5 faces, as it is same, there is no any involvement, so we can write 5 into, we'll write 5 into the surface area of one face. So what will be the surface area of one face? As the side is given 7 centimeter, so one face the area will be 7 into 7 means side square. So we'll write here 7 into 7 mean directly we can write 49. So 5 faces finished. Now we'll write this corner one. So corner one, how? We can subtract the circular part from the area of one face, mean the 6th face. So one face is what? What is the area? One face is, it is 7 into 7. So here we'll write add. Then 7 into 7, it is 49. But we have to subtract the circular part. So circular part, area of the circle is pi r square. So we'll write pi r square. So 22 by 7 into. Now what will be the radius? What will be the radius of this hemisphere? It will be half of the side. So it is 3.5. So we'll write here 3.5 into 3.5. Now that part also finished, mean these 4 corners finished. Now the hemisphere, the surface area of the hemisphere, and it is 2 pi r square. So we'll write plus, here we'll write 2 into 22 by 7 into 3.5 into 3.5. So you see it clearly. Here it is 5 into 49 plus 49 minus 22 by 7 into 3.5 into 3.5. This is, we can use bracket here. and the third one is plus 2 into 22 by 7 into 3.5 into 3.5. So this is now only to calculate. If we calculate, so 5 into 49 equal, it is 245, then plus, now 49, here it is 49 minus, then we can cut it, here will be 0.5. Now 0.5 into 3.5, we can multiply it in the rough side. So 35 into 5, without decimal you can multiply 175. So how many decimal? 1, 2 decimal. So we can put here decimal. So it is 1.75. So we'll write here 22. So let us multiply with 22 also together. So it is 22 0.583. So 2 decimal 38.50. So we can write here 38.5. Let it be in the bracket. Now plus. Now that part, here also we can cut it by 7. Here will be 0.5. Now here 44 into 5 into 3.5. Already we multiplied, it is 1.75. Now to multiply it with 44. So we'll multiply here 175 into 44. So we can multiply it here by 2 only because it is 22. So let us multiply again. 7. So it is 0077. 2 decimal is there. So here will be 2 decimal. So it is 77. So it is 77. So we can write here 77. Now 245 plus 49 minus 38.5. So it is better to subtract separately. So it is 38.500 here 5, then here 1, so 10.5. So you can write here 10.5 plus 77. So we can add it together now. So here 10.5, 77. If we add it here 255.5 plus 77. So it is 255.5 plus 77. So it is 5233. 332.5. So it is 332.5. The unit will be centimeter square. So this is the answer. So I hope you can understand. If any problem, so you can comment. So today, now I will start question number 5. In question number 5, it is given that a hemispherical depression is cut out from one face of a cubical wooden block such that the diameter L of the hemisphere is equal to the edge of the cube. Determine the surface area of the remaining solid. Now, from this figure, we can see that here, this is the diameter of the hemispherical depression, this is the diameter, and this is equal to the edge of the cube. According to the question, it is given. Now, what is the remaining part? After cut out this hemispherical part, we can just think that how it is looking like. So, we have to find this surface area of this remaining part. Now, it is given that the diameter is L. So if the diameter is given L, then the radius of the hemispherical part will be L by 2. it is L by 2. It will be L by 2. We can write here L by 2. That one means the radius of the hemispherical part, and side is given L. Now, one by one, we'll write like the previous one. Here we can see, in case of cube, 6 faces are there. 5 faces are same to same. There is no any problem. But in the 6th phase, the hemispherical depression is cut out. So 5 face will be same to same. We can write, as the edge is given L, so we can write the 5 face mean 5 L square. It is 5 L square for the surface area of the 5 face. Now in the 6th phase, we can see like the previous one. Here you can see the circular part we have to subtract. So we can write it plus the area of this face will be L square, then minus, we have to subtract which one? The circular part. So area of the circle is pi r square. So we'll write here pi, r is L by 2. So here will be L by 2 into L by 2. That one. Now the depression, the depressed part. So it is like a curve of the hemisphere. So curved surface area of the hemisphere will write. So it will be, let it be in the bracket, plus. So curved surface area of the hemisphere is 2 pi r square. So r is equal to L by 2. So here also L by 2 into L by 2 into. So this is our total mean surface area of the remaining solid. Now only to simplify, we'll simplify it. So 5 L square same to same plus, here it is, we can write L square minus pi L square by 4, then plus, here 2 to cancel, we can cancel it. So here pi L square. So it is pi L square by 2, that one, equal. Now it is clear that L square in all the 4 terms, 1, 2, 3, 4 terms, L square is common. So we can take L square as common. So L square we are taking common. So what will be left here? There will be 5 plus here 1, then minus, here L square taking common. So pi by 4, there will be pi by 4 plus here pi by 2. This is now equal L square into 5 plus 1, we can write 6, and then minus pi by 4 plus pi by 2 equal to plus pi by 4. So plus pi by 4 equal. Now we can write it. This is the answer also, or if you want to simplify, then we can write it L square by 4 into, here we can write 24 plus pi, or pi plus 24. So this is the answer. You can check it, this part carefully. I think you can understand. So today up to this. Thank you.